All right, so let's take a quiz over what you've learned today. How is the force of electricity similar to that of gravity, and how is it different? So similarities would be that the force of electricity is, they're both caused by something. So in the case of gravity, it's caused by mass. In the case of electricity, it's caused by electrical charges. They both can attract, but only electricity can do what? Only electricity can repel. How many different kinds of mass are there? Just one. How many different kinds of electrical charge are there? There's two. So there are some similarities and there are some differences between the two concepts. If a charge of 3 coulombs is placed in an electrical field of 10 newtons per coulomb, what force will it experience? Okay, so I'm setting it up for you here so that do it step by step and always have a way of doing these word problems. So what variables are you given in the problem? So we're given 3 coulombs, and we're also given 10 newtons per coulomb. All right, and then we're looking for something. So just put a question mark for that one. So look at the unit, coulombs. So, and it also says charge. If a charge of 3 coulombs. So if we go back up to here, you notice that coulomb went with charge Q. So we know that this was Q. Okay, newtons per coulomb was a unit for the electric field, so this was E. And then what are we looking for? What force will it experience? And force is given by F. So we're looking for F sub E. All right, now what equation connects the variables? So we had a formula that said that the force of electricity is going to be equal to Q times E. So now all we've got to do is plug your values in and then solve it. So we know that the Q is a 3. We know the E is a 10. So we're going to take 3 times 10 is going to be 30. So our answer is going to be 30. And then put an N on the end of it because it's 30 newtons. Okay, so that's how you'd solve the problem. All right, what does a capacitor do? So a capacitor stores 3 things. Electrical charge, it stores electrical energy, and it also stores the electric field. All right, what is a superconductor? So under ordinary conditions, it acts like a insulator, but it will become a conductor if you do what? Lower the temperature really, really low. So at very, very low temperatures, a superconductor becomes a conductor. But not just a conductor, it becomes a superconductor. And so it will not lose any energy if it generates an electrical current. That electrical current will not lose any energy as it's flowing through the wire. Another useful thing for superconductors is they make very good magnets. And so we'll talk about magnetism in a future lesson. All right, what is the electrical field inside a piece of metal? It's going to be 0. Because what will happen is if you put it into an electrical field, the electrons will rearrange themselves so that it makes another electrical field inside the piece of metal opposite to what caused it in the first place, and then when you add the two together, you get 0. So that there is zero net electrical field inside of a piece of metal. All right, so that is our lesson on electrostatics. So in our next lesson, we're going to talk about what happens when we take electrical charges and they begin to move. And that's going to make an electrical current. So we'll learn all about those in our next lesson. So I'll see you then.